Good morning, everybody. Welcome to Tibbetts Physics. What is crappinin'? Today we're going to talk about free falling, except not real free fall motion, with air resistance. So typically in physics class we neglect air resistance. Today we're going to look at what happens when we throw air resistance into the equation, which is more of a realistic situation. So let's first look at Mary Poppins. So let's see, we got our good old stick figure. She's holding her umbrella. And we'll say she's falling from the sky. And Mary Poppins currently has a mass of 58 kilograms. So let's look at Mary Poppins free falling, that'd be without air resistance, and we'll look at the net force acting on her. So if there's no air resistance, the only force acting on Mary Poppins is her weight, Fg. And we know that Fg is equal to mg, where g is the acceleration due to gravity, which is negative 9.81 meters per second squared. So that means you continuously fall at the rate of 9.81 meters per second squared, so her speed would keep on speeding up over time. Now let's look at her with air resistance. Now we have two forces acting on her. We still have gravity going down, F sub g, and the upward force acting on her would be the force of drag, F sub d. So let's use Newton's second law to look at the net force. We've got A equals F net over m. The two forces are force of drag and force of gravity, and the force is Fd minus Fg over m. And let's multiply m by the other side, so we have ma equals Fd minus Fg. The force of drag is just the wind that's pushing upwards against you while you're falling. If you ever stuck your hand out a window while driving a car, you feel that wind pushing backwards. This will be the wind pushing upwards. So let's expand this even further. Now we've got ma, so that's your mass, your acceleration, or Mary Poppins, is equal to m, acceleration due to drag, so that's the upward wind, minus mg. We've got m and m, so let's just cancel those guys out. We're left with your acceleration is equal to the acceleration due to the drag minus the acceleration due to gravity. Now, don't write this down, but if we ignored the drag force, the AD would go away and your acceleration would just be acceleration due to gravity. But now we have acceleration due to drag. So let's just do a few examples. Let's look at when AD is equal to 1 meter per second squared. What would be the acceleration of u? Well, let's figure it out. A equals 1 meter per second squared, and I'm going to use 10 for g instead of 9.81, minus 10 meters per second squared gives you negative 9 meters per second squared. So that would be your acceleration if there were an upward drag acceleration of 1 meter per second squared. Okay, let's look at 4. So when AD equals 4 meters per second squared, what would be your acceleration? Let's see. Acceleration is equal to 4 meters per second squared minus 10 meters per second squared, which equals negative 6 meters per second squared. So this means over time, if you think about when you're falling out of the sky, if you've ever done it before, you're going to start slowing down as the wind blowing up gets faster and faster. So let's look at another one. What happens when the acceleration due to drag is 10 meters per second squared? we get A equals 10 meters per second squared minus 10 meters per second squared. Acceleration is 0 meters per second squared. What does that mean to you if you're falling out of the sky and your acceleration is 0 meters per second squared? Well, that means, it doesn't mean you're moving, it means you are no longer speeding up. And you're just falling at a constant speed or a constant velocity. And this word is, the definition is terminal velocity. So if you are no longer accelerating, you've reached terminal velocity, and this has other factors that cause this. So in terms of the surface area, so if you have a greater surface area, you'll reach terminal velocity faster. Now what happens if this gust of wind comes up? So you're falling at terminal velocity, then something came up, and now the acceleration due to drag is 15 meters per second squared. What's going to happen to you now? Well, you should get your acceleration is 15 meters per second squared minus 10 meters per second squared, which equals 5 meters per second squared. That would mean that you are now moving upwards at a rate of 5 meters per second squared. So this is what it would look like if we have air resistance, but as you notice when we analyze physics problems, we neglect air resistance. That's it for me tonight. See ya.